My name is Craig Grant and this is Cobweb Maths. I'm a cobwebber with an action learning mindset and I'm on a steep learning curve. My last video on ratio was a step up. This video on factor walls is another step up. I'd like feedback from my viewers because feedback is the breakfast of champions. Now I'm going to show you a mind map, highlight the connections, and then present the lesson plan that I'm going to follow for this video. I'm doing this so you, the viewer, can understand what I am doing. Thank you very much. Okay, here is the mind map. We are focused on factor walls, however, multiples are closely aligned with factor walls. There's a very strong relationship there. We're going to use a concrete concept, basically wooden blocks. If you had, say, 12 wooden blocks, and you can use those 12 wooden blocks to find, say, the factors of 12, and you just make rectangular block walls. This is connection-based learning, all right? Because what you need to do is link mathematical concepts to concrete concepts, and if you can make that connection, because it's easier to make connections to concrete things than abstract things. Over here we've got simplifying fractions. Well, to simplify fractions you have to break down numbers into factors, and this is what factor walls does. And you will find a strategy for simplifying fractions in one of my earlier videos, and I'm going to use this same sort of strategy here, and we're going to do a bit of pattern-based learning. Now, mathematics is based on patterns, and if you know the pattern, you can learn mathematics. Now I'll show you the lesson plan. Make sure it's lined up and pretty well level, I hope. Right, the teaching plan. I'm going to use factor walls, and I'm going to use an example for a start. Find the factors of 12. I'm going to link this to concrete concepts. I've talked about concrete concepts. On the second part, I'm going to show you how to generate the key multiples that you're going to use to find factors, and I'm going to link that to the factor wall pattern. Then in the next part, I'm going to link number factors to key multiples. All right? And the last thing I'm going to do is I'm going to show you a strategy for finding factors, and I have used this strategy before when I simplified fractions, but rather than have you go back and find it, I'm going to repeat the strategy here in this video. Okay, thank you very much. Now I'm going to use finding the factors of 12 as my example. So you take 12 blocks and you're going to use them to make rectangular walls. So you start off and you make the first one 1 high, and that will give you 1 block high and 12 long. So it's 1 by 12. Then you see if you can make it 2 high, and you can. It's going to be 2 by 6. Then you try and make it 3 high, and you can. It's going to be 3 by 4. And that's as far as you can go. You could actually do it 4 by 3 and then 6 by 2, and you could make a big column of 1 wide and 12 high, but don't go there. Right, now the factors of 12 are 1, 2 and 3, 1, 2 and 3, and then 4, 6 and 12, 4, 6 and 12. Right, now we'll go and look at the block pattern. Hopefully you can see all of that, and I've got it aligned. I'll just nudge it a little bit. Righto. I'm going to use the numbers from 1 to 6. If you're going to do that, and you're going to do it concretely, you're going to need 50 blocks. And you need to set it out in about 3 rows on a table, and use a template like this. So this is for children to get the idea, it's a concrete way of doing things. So take the number 1, you'll just get a 1 high block. That's it. It's just there. It is there. Then you go to 2. Well, you can have 1 block high and 2 blocks long, or 2 blocks high and 1 block long. And it's actually important you do both on this one. You'll see why in a minute. When we take 3, we can have 1 by 3 and 3 by 1. When we get to 4, we can have a block 1 by 4, it's 1 high and 4 long, and 2 by 2, so it's 2 high. Then we get 1 by 5, and that's all we can get with that. And then we have 1 by 6. We get 1 by 6, 1 high, and we can have 2 high and 3 long, and we can have 3 long and 2 high. And you could set this out and use this as a template. So you'd have these 6 block walls in a row there, and here every second number, right? Every second number has a block wall, and over here every third number has a block wall, right? And these actually are the multiples of 2. You see that the first multiple of 2 is 2, the second multiple of 2 is 4, and the third multiple of wait a second, what's going on here? 2, no, that's right, yeah. And the third multiple of 2 is 6, that's right. The third multiple of 2 is 6. And if we go down to the multiples of 3, the first multiple of 3 is 3, and the second multiple of 3 is 6. And this pattern carries on, and I'll be talking about that pattern later on. So this is quite important. I'm going to make up a template that teachers could actually use. If you're a parent, you can use this, but it's quite powerful. Right, now I'm going to link factor walls to multiples. Let's just take the first 4 multiples of 2. That's 2, 4, 6, 8. 1 lot of 2, 2 lots of 2, 3 lots of 2, 4 lots of 2. Now here's a diagram. Here are the factor walls which are 2 high. That's 1 high. That's 1 wide. That's 2 wide, that's 3 wide for 6, and that's 4 wide for 8. And it's 1 by 2, 2 by 2, 3 by 2, and 4 by 2. Now let's go to the factor walls associated with the multiples of 3. The first 4 multiples of 3 are 3, 6, 9, 12. Now the first one is 3 high and 1 wide. Second one is 3 high and 2 wide. That's 3 wide, and that's 4 wide, and they're all 3 high. Now, we have a look at 6. There's 6 over there, and there's 6 there. Now we know 6 is equal to 1 times 6, but you see in this diagram, it's 3 times 2, and over here it's 2 times 3. So 6 is also equal to 2 times 3. So the factors of 6 are 1, 2, 3, and 6. You see, 1, 2, 3, and 6. Right, let's flip her over and look at the key multiples. Now, I'm going to go through generating the multiples now. I use tally marks. You put a couple of tally marks there, and what you do is start at 2, 3, 4, there's 4. Then you go 5, 6, and you get 6, and so on. See, if you're doing 7, you put down 7, and then you go 8, 9, 10, 11, 12, 13, 14 there, and then you go 14, 15, 16, 17, 18, 19, 20, 21, and the next number would be 21. Now, these multiples all carry on, Over here, the key, there's only two multiples you have to know for the 7 times table. I wrote for multiples of 7. That's 7 times 7 and 7 times 11. Now, to simplify fractions, like look at this fraction here, 12 over 21, we split it into factors. So 12 is 3 times 4, 21 is 3 times 7, we cancel out the 3's, and that's 4 over 7. So that's where we use finding factors in simplifying equations. Now, these are the rules that you need to know. Numbers that are even end in 0, 2, 4, 6 and 8 have a factor of 2. Numbers that have digits that add up to, missing 3, add up to 3. Add up to a number that is divisible by 3. Well, add up to numbers. No, wait a minute. We better go back to that. Numbers that have digits that add up to numbers that are divisible by 3 have factors of 3. Next one. Numbers that end in 0 or 5 have factors of, not 10, have factors of 5. Numbers that end in 0 or 5 have factors of 5. Now you need to check off the factors of 7, and there's only 2 you need to check on. That's 49, which is 7 times 7, and 77, which is 7 times 11. That's for 2-digit numbers. So look, I'll just run through this whole thing again. Must make sure we get it all straight, because I made some mistakes. Right. Numbers that are even end in 0, 2, 4, 6 and 8, and they have factors of 2. Numbers that have digits that add up to a number that you can divide by 3 are also have a factor of 3. So if you had a number like 42, if you add 4 and 2 you get 6. You can divide 6 by 3, so 42 is divisible by 3. Numbers that end in 0 or 5 have factors of 5. And there's 2 factors of 7 you need to check on. That's 49, which is 7 times 7, and 77, which is 7 times 11. And you do use this strategy. You start here with the factors of 2 and work through the factors of 7. And you need to note, this is in red, so I hope you can see it, but if you can't, I'll read it out. Numbers that end in 0 have 2, 5 and 10 as factors, because 2 times 5 is 10. They've got to have a factor of 2 and a factor of 5. They've got a factor of 2 and 5, they have a factor of 10. If a number has a factor of 2 and a factor of 3, it also has a factor of 6. Now we're going to do an example and find the factors of 24. Right, finding the factors of 24. 24 is even, so 24 is equal to 2 times 12, because 2 is a factor. 12 is even, so there's another factor of 2. Well, that means 4 must also be a factor, so 12 is equal to 4 times 6. Now, when we add 2 and 4, 2 and 4 is 6, 6 is divisible by 3, so 24 is divisible by 3, so 24 is equal to 3 times 8. And we must also remember that 24 is equal to 1 times 24. Now here are all the factors of 24. There's 1 and 24, 2 and 12, 3 and 8, 4 and 6. Now we'll get the next board. Here it is here. And it may in actual fact be easy to use the prime number strategy. So I'll just show you the prime number strategy. I take 24, which is 1 times 24, and I've done that in blue, so I won't forget it. Then I've done the rest of the working in black, because we're going to find the prime numbers. 24 is equal to 2 times 12, right, because 24 is even. Now 12 is even, so we can break 12 down into 2 times 6. Now 6 is even, so we can break 6 down to 2 times 3, and then we can't go any more. So we've broken it down into prime factors. Now this is what we've got to watch out for. We haven't covered all the numbers that are factors though. See, 2 times 2 is 4, so 4 is a factor, and 2 times 2 is 4 times another 2, means that 8 is a factor. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12 and 24. Now I've decided to add in a thinking person question because you need to do something and make sure you've got all this stuff straight in your head. Now here's the thinking person question. Find the factors of 42. Now, so I want you to pause the video. If you haven't got pen and paper, go away and get pen and paper and try this question. And then I'll show you the answer. Okay? And it doesn't matter if you don't get it right, because when I show you how to do it, you'll understand, and you'll probably go for this prime number strategy, because I think it's probably the best of all. Okay? Right, here is the answer to the factors of 42. We just take 42 and it's even, so it's 2 times 21. Then we split up 21 and we get 3 times 7. So they're the prime factors. Now we can put 2 and 7 together and get 14. And we can put 3 and 6 together and get, 2 and 3 together and get 6, right? So as a check, we write down all the number pairs that will multiply together to give us 24, so we don't miss anything out, because it's very easy to miss it out. I nearly missed out this 2 times 7 is 14. Alright, here we go. Now, we've got 1 and 42, 2 and 21. Now 3 times 14 is 42, and 6 times 7. So the factors are 1 and 42, 2 and 21, 3 and 14, 6 and 7. And we're done.